Okay, so we have a 14 inches that's coming in for no power. I'm sorry, it powers on, but it doesn't detect the battery. So they this has already been assessed. It's coming from a different company, a repair company. So just a couple of things. The battery has already been replaced. So they wanted to, as you can see here, you have a test battery installed on the device. So say again. Okay. So you can see that the battery is loose. That's because they try to put in another battery just to see if the issue is from the battery. But it's not the battery, because even with the battery, it's still the device still behaves the same way. So so I'm going to demonstrate to show you guys exactly how it behaves. And then I'm also going to demonstrate to you that I always stress that when you're doing a troubleshooting, you need to understand the state of your device. If you do not understand it, you might lose your troubleshooting track, which would then really throw you off, and you might be chasing after something that is not going to help you in any way. So I'm going to demonstrate to you, and also the one thing that they were concentrating more on the battery not being detected, but what else they did not what else that should have also piqued their interest was the way this is supposed to function. It's whether the battery it's connected or not. When you have your charger plugged in, there should be an indication on that the charger is plugged in by the battery icon. So whether you have your battery connected or not, there has to be an indication. Now, sometimes depending on the operating system that you have, if you put the device to desktop, and before you input your password, you might not actually see the sign of the charger being connected. But then, if that is the case, is the best thing would be for you to put it into recovery, because while you're in recovery, you will be able to see. And by the way, even though you do not see the battery icon, the charger icon on the battery icon on your desktop before the password is imputed, the battery will increase because it is charging. So what you can do, especially in a case like this, is go into recovery and see if the charger icon is present on your battery icon. So one thing that I notice here is whether the battery is connected or not, the charger icon is not. There's no indication of the charger icon, even though the device will power on with the charger. So what I'm trying to say is the battery being detected, it's going to be secondary. So this is this is not really going to be the case of the battery not being detected. You have to have one before you move on to number two. In this case, the primary thing is your battery, the cable, the power, your adapter, your charger has to be represented before you move on to the battery charging. Because if your power cable is not represented or is not detected properly, because partially the device powers on with the charger, but it does not charge the battery. And also, when you go onto your battery icon, you don't see any sign that the charger is what is connected. I'm just going to show you guys something. So this is my battery, for example. So if I am to connect my charger to it, if I'm to connect my charger to it, so one thing is obviously there's going to be the feedback sound, there's going to be the LED, and also you will see that sign there. Let me just see. So you see that sign is going to be present. So if I disconnect, the sign is gone. If I put it back, you see that, and then obviously it's going to transition into the lightning symbol to show that the device is charging. Okay. So that's that. But on this device, it doesn't do that. So I'm just going to show you guys, and as you guys can see, the screws are out. So I'm just going to show you guys what the device does. Now, the device, it doesn't matter if you use a SIF3 or USB-C, it still behaves the same way. Okay, as you can see, you have your LED, the device is on. Uh, and they also the device has no operating system, so we are not able to go into the operating system. They also tried to reinstall the operating system, they couldn't do that. So now the way it behaves this way because there is no operating system. So now we're putting into recovery. So let's go into recovery, and then I'll show you guys what I'm talking about. And also another thing the device also does, I hope I did mention that the device itself is liquid damage. Another thing it also does is sometimes it restarts. So especially when you click on to continue onto your recovery, the device restarts. So let's see. Now this is what I'm talking about. As you guys can see, the battery is on 0%. Now the charger is connected, and it doesn't show that the charger is what is connected. Now, so now I just want to show you guys. Obviously, if I disconnect my charger, the device, say the battery is on 0%, I disconnect my charger, the device is still on. Okay, now it goes off obviously. Okay, but I'm just gonna show you guys something. So assuming we disconnect the battery cable, that's the data cable for the battery. So which would then mean now that the battery itself, it's okay. And then just for to show you, let's also remove the main battery power line. Okay, the main battery power line is also disconnected. I have to connect my trackpad, otherwise I'm not going to be able to use the trackpad. So even at that, you will see that the device is still going to behave the same way. So by behaving the same way, it's I mean, as it is now, the battery, though the charger is not, the battery is not connected, we should at least see the charger icon because the device is being powered directly from the charger. But still, you're still going to have the same behavior. See, it also does that. It shuts off and then it has to restart. And then another thing you guys also want to notice is when this device powers on. Okay, let's discuss that later. But then you just have to understand that you see sometimes when the device goes off, at the point it goes off, the LED also goes off with it. Do you understand? So I'm just gonna show you guys what I'm talking about. Just watch this. See, it's off. The LED will go off temporarily, and then it comes back on. I'm gonna explain that in details, but for now, I just sometimes just want you to just wanna point that out to you. You see, we generally with the M series, especially the ones with the Safe 3. So what happens is when the device goes off, there is a temporary reset that takes place, obviously, which would then also turn on the LED just temporarily, and then it will go back on. Okay, so let's see. So now the battery cable, the battery data cable, as well as the main battery panel has been disconnected. uh, and as you guys can see, with the battery still behaves, it's still exactly the same thing. So that it says the battery is 0%, and there is no battery there's no charger icon there. So I'm just going to disconnect it. Obviously it goes off. I want to show you guys how it should look like. I'm just gonna use another device. Okay, so this is an M2. So you guys will see that it looks exactly like an M1. You wouldn't even actually be able to tell if you just by looking at them. So it's 1, 2, 3, 4. It's okay. Bear with us. The battery is the screen is full, but then at least you can see something there. Yeah, you can see when the charger is connected. You see the lightning icon. If you can see it, yeah. Okay, I'm just gonna go to restart the device to go into recovery. and this is a fully working device. The only thing is just a screen. So as you guys can clearly see there, we have the as you can clearly see there, we have the lightning icon. That's because our charger is connected. If I'm to remove my charger, it should disappear, and then you only have the battery. I'm gonna put my charger back, so you can clearly see. So even when we go into recovery, you will still see the same thing. And this is with the battery connected. So I'm also going to show you guys when the battery is not connected. So it clearly tells you that the battery is at 77%, and you can see the lightning icon. If I remove it, it should go off. The icon should disappear. Give it a bit of time. Okay, yeah, the icon is gone. So what I want to do is I'm going to okay, let me disconnect. So what I want to do now is I want to disconnect the battery. So I basically want to replicate the same state of this device, so you see how it should be. Uh, just trying to draw attention to what I'm trying to say in terms of the behavior you're supposed to expect. Because I mean, you shouldn't focus on the battery being detected first. You should focus on addressing the case of the okay. You first have to address the case of the charger not being properly identified. Okay. And then while you're here, I'm just going to show you guys something. Now this is the M2, and this is the M1. So some of the changes that you will notice is the footprints of the SSD on the M1, it's obviously going to be different from the M2. So you see the footprint of the SSD for the M2 is a little bit tinier compared to the M1, which are bigger. Now, and then you will see that the 5-volt line for the M1, you see the 5-volt regulator IC that is used, you see it's a bit bigger in terms of size. And then look at the 5-volt regulator IC that is used for the M2. Now that's going to be that's also going to be the case of the M3. So basically, one of the ways you can identify the difference. Yes, one way it's the board number. You can use the board number to obviously to tell the difference. And then another thing is the type C, the port that is here. The controller is placed on this side of the board for the M2. Now for the M1, the controller is not placed on this side of the board; it's placed on the other side of the board. So there is no CD3217 anywhere around here. But the M2, you have the CD3217 on the other side of the board, which is here. And also, if you look at the heatsink, it's very different from the heatsink of the M2. You see that? See how the heatsink look compared to the heatsink of the M2. That's just some of the changes that right away you will notice, and obviously the board number will obviously, that's M3 and above. Okay, so let's disconnect the battery. So I just want to make sure that we are is in exactly the same state. So I'm going to also disconnect the battery power. Disconnect the main battery power cable. Okay, so it's connect and see what we get. Did I just put it off? What is okay, fair enough. A long delay. Okay. So as you guys can see, there is still a representation. You can see that. Hmm? See that the icon is still present. Um, it might be difficult for you guys to see. So, but the icon is still present, and as you can see, obviously because the screen is damaged, yeah, you don't even see it anymore. Okay. Anyway, you can see that the icon is still present, and obviously, okay, I think now you can see it there. You can see there. The icon is there, and it is telling you that the battery is on 0%. So but in the case of obviously, as you guys saw, that charger disconnected, it goes off. So with our guy here, so first thing we notice is that the charger is not properly recognized. So I was on. Okay, so it's so you say it says the battery is at 0%. It does not. It doesn't tell us that. I mean, you will assume that the device is being powered off from the battery, but in this case, the device is being powered off from the charger, and there is no indication that the charger is connected. So that's what we want to figure out. Now, just something I want to say that in this type of repair, your focus shouldn't be the battery not being detected. The reason why we had to go this length to show you that the battery is disconnected, the battery cable disconnected, and then also use a different device is to tell you that the behavior that you're getting, first, you should first worry about the charger being properly recognized by the device. And then after that, it's sorted out, then you worry about your battery. So the idea shouldn't be about worrying about the battery not being detected, because right now the battery being detected is secondary. Primarily, the charger has to be properly recognized. I don't know if you understand what I'm trying to say, because I mean, what they did was they needed another. They had to put in another battery just to be sure if the issue is the battery. But I'm saying the battery is secondary. Primarily, even with the battery not even without the battery being present, the charger should be properly recognized. And in this case, that's not what it's doing. Okay, so and then also a repair like this one. So just as you see, this is a Maxi 3 cable. The behavior is the same. Even when we do use, I'm going to use a Type-C cable. Let's use a Type-C cable. So the reason why I'm using the Type-C cable is just that I just needed to draw your attention to something. But then before that, I want to obviously use a cable so that it makes sense what I'm trying to say. Give it a bit of time. Okay, so now, as you guys can see, we still have this. We still have the same state. Now, the reason why I had to use a Type C. Now, an issue like this one, you are not having an issue that has anything to do with the charging port. So the reason why I had to use a cable is so that I'm able to pass the message across. This is not an issue that has to do with the charging port. Do you understand? Because if it was an issue that has to do with the charging port, you would obviously have you probably have Maxi 3 behaving a certain way and the Type C port behaving a certain way. This has nothing to do with the charging port, because as you understand, the device powers with the charger. It's the device does not recognize the charger. Now this is going to be a data issue. This is going to be a data issue. Yes, the device is liquid damage, so our focus is not going to be on the charging port controllers themselves. The charging port controllers are doing their work. Now the issue that we're having, it's a data issue, which is the device does not fully recognize the presence of the charger. Even though the device powers off of the charger, the charger is not fully represented. So I just had to obviously point that out, so that in your troubleshooting, do not start looking into the charging ports, because this has nothing to do with the charging port. This is a data issue. This is a data issue which would obviously has to do with the charger communication, not from the charging port level, but beyond that. Because as you know, the data communication that we're talking about now, it has something to do with the charging port controllers in this case, which is the CD3217. Okay, so that's that. So the next thing we're going to do is, as you know, the screws are already out. So now we are going to take the board out. What now? There is the section that we are going to be looking into. Okay, just for time's sake. But primarily, I'm just going to show you. This is the board. This is a board view. It's okay. So this is it's have the board view open. I'm just gonna show you guys something. So my I'm gonna be very much focused on this section of the board here. So on the other side of the board, I'm gonna be focused on here, this section here. You see where it says UD 290. So there you have the I2C communication. So that's the I2C underscore SMC. That's the current SMC line. Let me see. The other one is the UD 102. That's the I2C SMC power 1.8 volt. Let's see what the other one says. That's the NAND. So I'm going to be more interested in what is happening in this section here, UD102. And this is a current sensing, that's the current sensing section of it, which is I2C underscore SMC underscore, the current sensing, which is the system clock line is going to be your SCL, and then SDA is your system data line. So SDA is system data line, and SCL is going to be your system clock. So obviously that's your SMC, that's SDA is data, with our SCL. SCL is going to be a clock. So that's your clock, and that's your data. Okay, now we're going to take the board out and really see. But like I said, that's that section of the board. I'm going to be interested. I'm going to be looking into see what is it that I have in that section of the board. The screws are already out, so let's quickly take the board out of the shell and see what it looks on the other side. Like I did mention before, that the board itself is liquid damage, because they mentioned that there was a liquid spill. So we're going to be, and then also when it comes to, as you know, when it comes to a liquid damage board, it's pretty much direct, because with liquid damage, it points you to exactly, you can see what has happened and what the liquid has affected, and generally your troubleshooting will start from there. And then another thing is, when it comes to liquid damage, so one of the ways you obviously address the liquid damage, it's so one thing is, you see where the corrosion has taken place. The next thing you want to do is, you want to ask yourself, this region of the board that is corroded, what function does it hold? What does it do on the board? So that you know when to continue working in that section of the board, or when to stop. Do you understand? So if the function, if for example, if you have a 2.5 volt line, if you have a 2.5 volt regulation circuitry on the board that is affected by liquid, if at the output of that circuitry you have 2.5 volt, remember the function of, or the purpose of that rail, or that circuitry, is to create or to regulate 2.5 volt. If you have 2.5 volt, it means the circuitry is doing its job. What do? You move on. You don't still continue to. However, there are cases where the circuitry doesn't look, even though even though you're getting what is supposed to, but you can clearly see that this is not, the components here are not, or this is not going to last long, given from what you can see from the damages sustained from the liquid. Then in that case, you want to replace this component. But other than that, if it is something that you can basically walk around, then you walk around. And then another thing I want to mention is the effect of a particular section of the board, the effect that will be sustained by a particular section of the board is dependent on how much voltage that section of the board holds. Say, for example, if you apply liquid, if you put a liquid on a 1.5 volt line, and put liquid on a 12.5 volt line, the 12.5 volt line will basically eat into the board quicker compared to the 1.5 volt line. So the reaction on the higher volt is it's quicker, it's more rapid compared to the reaction of a lower volt. So that's that. So now let's quickly take the board out and see what's happening on the other side. That will give us an idea of exactly what's going on. Typically, I want to remove the board from this section because this side, obviously, you have an extension of the HDMI port on this side, which here you don't have. Do you have? Did you put screws back here, or what's going on? Oh, I thought you removed the screws already. Did you put them back? Can you confirm what time is it? Okay. Just let me know because I said it's about 4:16. Can you just put that somewhere? Just you don't have to hold it that way. Okay, so while you're taking your butt out of your shell, just be careful. Just know that some of the cables here can be replaced when they are broken, but others cannot be replaced. Others are paired to the board. So some of the cables that you have to be very, very particular and very, very careful about. It's going to be the Touch ID. That's number one. The Touch ID cable. As you can see, the cable is it's a tiny cable. So this breaking it's very easy. And then also you want to be careful the screen cables as well. The screen cables, because once these screens are damaged, once these cables are damaged, it's a whole job of having to remove the panel from the LCD and replacing the cables. And then if this is damaged as well, which is the angle sensor cable, then this is also paired to your board. When the angle sensor cable is damaged, you have to get, so if somehow this angle sensor gets damaged, so what you need to do is you need to remove that cable and then transfer the programmed IC on the angle sensor cable onto a different angle sensor cable. So the program chip is actually it's here, so you transfer that onto a different angle sensor cable and it's going to work. If you do not transfer the program, if you don't transfer it, what will happen is the device will not detect when the lid is closed or open. Okay, so that's that. Do you have any question before we move on? Do you have any question on your side? Okay, so I did obviously mention how you are able to differentiate from an M1 to an M2, and okay, so it's fine. We can talk about that at a later time. But then just something that I want to mention: if you look at the charging port for your M1, you see the charging port for your M1. You see that? So the charging port for your M1, it has no barcode, correct? Now, when you see a barcode on your charging port, it's definitely not an M1. And then something else to look out for, when you use an M1 charging port on an M3 or with a board that has a barcode, it's not going to work. Do you understand? So that is something also. So you don't just grab any charging port and just use it thinking no. So let me just see if I have any here. Even though they will look exactly the same. Okay, so you see now, so you have two charging port here. One it's barcoded and the other one is not. So the one that is barcoded, when you're using it, especially this is something that we did on the M3s. So you will see that the charging port for the M1 is not going to work on the M3, and then with M3s you see that it will come with a barcode. Okay, so that's that. So now that the board is out, let's put this on the side and then let's see what's happening on the other side. Okay, so generally what I'll do is I'll do a scan of my board. I did mention that you can either do your scan from the right hand side, or you can start from this side or from the other side. So whichever side you start. Now, okay, so do you see that section there? You can see that section. So you can clearly see we did talk about that section, and every other section of the board seemed to be fine, but that guy there, you see that? And that is going to be, that's UD290, correct? That's a section of UD290. it's very interesting that it almost now you might ask, why was I pointing towards this section? It's because of what this section does on the main board, and also it is also because so usually one of the amazing, or one of the good things I like about the Apple design projection, or Apple design, is that you are able to follow up the design from one year to the other. So say for example, if this was a 2012, let's say this is on a 1278 MacBook Pro, board number will be 820-3115. The way that the battery, the charger, it's recognized on the board, it's going to be centered around the SMC, correct? Now, in this case, we know that this is the design is slightly different from that of the Intel as well as the M series. Now, in this case, when it comes to here, it still says, for example, it still says I2C. It still says I2C underscore SMC underscore SN. SO, obviously, serial SNO. SNO, let's see, it's CSDA. And even though you have UD104 that looks exactly, UD104 is going to look exactly like UD102, but then our concern is only going to be UD290, and obviously the I2CSM underscore power 1.8 volt underscore SDL. Now, um, the reason why I was more concerned here, it's number one is I have had experience in having similar issues, and then obviously you being able to understand the design of previous models, and then having to use that to obviously understand the designs of later models, in this case an M1 design. It helps you to navigate, to know where to go to when you have a particular issue, and where to look. So, which is why I was more particular to say we are going to be looking into this section of the board. Interestingly, I mean, obviously, you guys, so when you have an issue like this one, obviously, and then there are other issues that might not be that might not be exactly the way we're having it on this board, that will also find themselves here. So sometimes you find that the device will work, and other times it will just shut down in the process of you busy with the machine. But then again, sometimes it gets very complicated in terms of how to properly explain it and how to properly tie a particular issue to a particular section of the board, especially in repairs. You cannot fully tie a particular issue to one section of the board to say, okay, if this fails, it must behave. No, sometimes it doesn't behave that way. Sometimes it behaves that way, and other times it will not behave that, which is why every time you have a machine, you just have to understand what is going on, and then from there you can offer a solution to that particular board. You cannot have your mind locked to say, okay, if I have this issue, it must be resolved in this way. No, there are other failure that might present themselves as though you're having an issue. Like, for example, like I said, the first guys that did the assessment on this device, they were more concerned about the battery not being detected, but that is secondary. First, you have to have proper charger communication before you can worry about the battery being detected. Once your charger communication it's fully established, the battery will naturally, because now once we have the charger properly connected, properly recognized, then what it would then mean is when the battery is connected, the battery will charge, because we don't have an issue of the, because if we had an issue of the battery not being detected, so we will have the charger representation. We will see we can see that the charger is present when it's connected or is not connected. However, when you remove it, the machine does not transition from the charger voltage or from charger power onto the battery power. So that's that on that. So we are obviously going to address that. So, and usually when you're walking around a section like this, you want to be very very careful, because you don't want to ruin your chances of getting it getting the repair. right? So what you want to do is you want to be very careful with the pad. So especially in this section of the board, you want to be very careful with the pad. So mm, about three resistors are out of place. So it's 1, 2, 3. So let's see. So the three resistors that are out of place is one, RD 177, RD 296, and RD 297. So let's see this guy. I2C underscore SMC power. So that's not present. And then obviously, um, so this, let me see. Okay. Among these resistors that we have that are not present, this and that line is tied. So among these resistors that are not present, the most important one here is going to be this guy, RD177. It's the most important one. Why? Because that is, so the 1.8 volt that powers this guy here, UD102, UD102. Okay, so you have you have the 1.8 volt on this side, and then you have the 1.2 volt on this side. So this is going to be present, but the 1.8 volt, it's going to be present through this resistor here, which is RD177. And if this is not on the board, obviously the power for the on the pin 3 is going to be missing. So we will say that the most important one that is missing, that is not present here, is going to be this guy. So the first thing we're going to do is we're going to start by, obviously we're going to replace all of it, but so this we must have it replaced, and then that, and then that. So we have this and that. So hopefully UD290 is not affected, because so we see there's a liquid around. This is a capacitor, and then yeah, it seems to be lots of liquids also on UD290. So we might have to replace that as well. We might have to replace that as well. So we are going to clean that section of the board to see if we are able to still reuse the pads that are there. We need those pads to get a Okay, so what we're going to do is first we're going to go for Salah, and then when we come back we'll continue, because it's time for Salah now. Okay. So what we're going to do, as we know that RD177 is affected, not only is the resistor itself affected, the pads are also not present. So what we had to do was we tried to see if we can reveal any pad for the I2C pad, as well as the 1.8 pad. So we have replaced RD's 17.7. So we basically want to test the theory of having to only replace RD 177 first before we worry about the current sensing section of it. So first we have tried to replace RD 177. However, because the pad for the pin 1 for the resistor, as well as the pin 2 for the resistor, were completely gone, we did try to see if we can get any of the pads to put the resistor back, which we hope we did. So now what we are going to do is we are going to see, let's see if we can, let's see. Okay, we have a communication line on U5200. That's the ISL, as well as UD102. Okay, so what we first thing first, we're going to see if we have communication between RD178 and RD177. That's a pin one of RD177 and pin two of pin one of RD179. We're going to see if we have we're going to use check for continuity between this pin and this pin. Do you know why we need to do that? To see if we have communication between if we have communication between pin 1 of RD77 and pin 1 of RD178. Do you know what we need to do? See if we have communication between those two lines. Say again? Yeah, but why? Why do we need to do that? Yeah, so I know, but why do we need to do that?
Because we replaced the this particular
The resistor?
the resistor.
Yeah.
So I want to know if the replacement well or
My concern is not the resistor. You should think about what you say before you say. Don't just speak. What does a short have to do with what we are talking about here? I explained to you guys that, I mean, I didn't even have to explain to you guys. You guys saw that we had this pad and this pad uh, were obviously not present. So we had to find a way to create the pads. Now that we have replaced the resistor, we need to make sure that the pad is basically okay, because we had to find a way to regenerate the pad. So in order for us to confirm that the 1.8 volt line is still fine, is to check another one and obviously check, so say the line between this and this, to see if there is a continuation between this line and that line, because obviously the pad here was missing. So what do you mean by short? How did the short come into this? What? Don't just speak for the purpose of speaking. The whole idea is for this to make sense to you. We didn't pad the pin one of RD177 was missing. Pin two of it was missing. Um, Now I'm also obviously going to, because I was also going to establish communication between pin 2 and the next point where this communication line goes to. As you know, this it's under a chip. We are not able to reach that. I checked the other side, it goes to the ISL. We're also not able to reach that. But I'm not too concerned about pin 2 because it seemed that we still had a pad on the pin 2, but the pin 1 was the one that I'm more concerned about. So if I'm looking for continuity between this and any other pin on the 1.8 volt line, I'm just trying to make sure that the pad that I'm using here is still connected to 1.8 volt line. I'm not concerned about the resistor itself. So the idea of the repair is for you to follow and to know what I'm doing and why I'm doing what I'm doing. That's the only way it helps you, so that when you're also doing a repair, you know while you're doing what you're doing. If you're there but you're not really there because you don't even know what's going on, for me it's a complete waste of your time, and I don't know. Anyway, we continue. So we have replaced RD177, but before we continue, we are going to check to see if we have if this line here, this pad here, and any other pad on 1.8, but we're going to use this because this is the closest that we have. See if we have communication, or if this and this is connected. If not, we obviously have to take a wire from here and bring it here. But then even before we do that, before we take a wire from here, if we don't have communication, the pad that we use here, we need to find out which pad that is, because we do not want to tie 1.8 volt line to a line that is not supposed to be. So let's start by checking what so what I also did was, because I didn't also want to waste your waste I mean, to make the video too long, so I had to replace the resistor off cam. So I'm just gonna show you. So this is the resistor here, the one that we replaced. You see the other two, we are yet to deal with them. As you can see, the parts are not And also this resistor here doesn't look so healthy. There was also corrosion under this chip. We are still not going to worry about that. Let's just first of all worry about this resistor here. So I'm going to check my pin, this pad here, and this, and see if we have communication. So I'm gonna use a continuity. My multimeter is gonna be in continuity. So I'm gonna have one pad here, and obviously, another thing I want to say is, you see, the way I want to measure that. So especially because we are busy working there, when you are going to place your probe, you make sure you don't place it in a way that it pushes the component, especially in this particular case, because if you do that, chances are that you will rip the component off from the board. So what you do is you be careful not to obviously place it in a way that it will destroy that component. Do you understand? So I'm not going to press it like this as if I am pushing my probe against the chip. Rather, I'm just going to gently place it on, just enough that I am able to establish communication. So that's what I'm going to do here. So I'm going to have this side and this side. So we don't have communication. Same. So I'm just going to clean it just to be sure that I'm able to. And another thing is because of what's going on in that section, I'm going to avoid doing this. Rather, I'm just going to do this, just so that I don't. I'm just going to check again. Okay, so that pad, so that's a wrong pad. So what we are going to do, since that's a wrong pad, we are going to remove that resistor from there, and then flip the resistor to this side. So what we are going to do is so since that's a wrong pad, now you understand why we need to make sure that we have communication. So we don't have communication between this pin and that pin, which would mean that the pad that we're using it's a wrong pad. So what we're going to do is we are going to flip the resistor this side. So our pin 1, we're going to flip it facing this direction. So pin 2 obviously is going to be there, but then we'll flip the resistor this side, so that we can now find a way to join the resistor to this. Do you understand? So we are going to remove the resistor from here, from this pad, obviously, because this pad is not, there's no communication between this pad and this pad. We're going to flip the resistor so that it's facing this side, and now we have a short gap between this and this, and then we can now connect it to this, so which would then mean that pin 1 is now going to face up, and then pin 2 is going to be, do you understand?
I see. I'm not going to use this port anymore.
I think your shadow is just make sure your shadow is not, that's all. You don't have to step away. So okay, so what we've done is we basically had to, and then another thing I want to mention is this section of the board absorbs heat more, obviously because that's the section of the board where you have your CPU. Yeah, so you get so that it absorbs. So that section of the board is not the same as is not the same as the other part of the board. So there you get there's so much heat, and you really have to turn off your hot air station in order for you to be able to remove components from this region of the board. Okay, so what we have done, we have basically removed our D177 because we do not have the pad for 1.8 on where it's supposed to be, and then we decided to flip it. So now we now have to find a way to join pin 1 and the resistor so that it ties to 1.8. And then after we've done that, the next thing we are then going to do is we're going to then make sure that we check for communication between this pin and any other 1.8 volt line, just to be sure that that section of the board was not cut off from here in some way. Okay, so it's now. So I just had to put a solder blob between which would be pin 1 for of this resistor now. As you know, we flipped it. And then, by the way, as you know, this particular resistor has no polarity, so which means there is no direction. So there is no pin 1. The pin 1 is on the board, not on the resistor. So however when you flip it, you are not nothing. I mean, you're not doing anything wrong. So even though I'm no longer using the pin 1 of it, which it means that I flipped pin 1 up in order for me to join it with the pin 1 of this. But what I'm trying to say is it doesn't matter which direction I use. Whether I use pin 2 of it to be pin 1 or pin 1 to be pin 2, it's fine because the direction, it's not on the chip, the resistor, rather on the board. Unlike a polarized capacitor that it has to go in a particular order, in a particular direction. This particular resistor doesn't have to go in that direction. So whichever way I flip it, the idea is I need a 1.8 volt line. I need a 1.8 volt, which I didn't have on this pad. So what I did was I had to move the resistor up so that I have one pin here of the resistor, and then the other pin will connect to 1.8 of the other resistor. So the next thing we're going to do is we are now going to see, yes, we have joined them, but now let's see if we have communication from, let's use a far up this side of the board, see if we have a combination between that section of the board and that section, and then we use something below it also. So we the top and something below. So we can say, let's see, do we have anything we can then, and then we can check here. So we check here the bottom and the top. Do you understand? Just to make sure that there is no break on the top nor at the bottom. Do you understand? So first, let's check the one on the top. Let's see if we have communication, continuity. So we do this. So we have that, and then this one here, that, and this. Okay. So at least we know that the line is fine there. So the next thing we're going to do is remember we said we are not going to worry about UD9, UD 290 for now. We are only going to worry about the voltage that comes in to RD 17.7 first. We are going to tackle this, but that's going to be later. And why are we doing that? Because this is a consistency line. But then something else I need to mention. The MCD's design, they are very sensitive. So there is a possibility that because the sensor line, the section of the sensor circuitry being affected will also prevent this section here from working the way it should. So, but nonetheless, let's check that out. And then something else we also notice is RD191 is not looking too good. So what we are going to do is we are going to see what is it that we have on the input of the RD191 and the output over of the chip. Let's see if there's a way we can because if you see okay, so actually let me see what we can do. It's okay, first thing first, let's test it. Let's see what we have. Let's see what we have. Wait, wait. No, we're not dealing with this. We're dealing with that. I was going to say, well, this is a capacitor. How did we mean stand for resistor? So this is what we're dealing with. RD177. Okay, so let's put this in the board, in the shell, and see what is it that we have. Try to connect as fewer cables as possible for what we need. We don't need the keyboard for now. We need the power button. We have the we need the power button in case we want to shut it down and put it into straight into recovery. Obviously, we know that it has no operating system, so but let's just have the power button connected. We really don't need that. Okay, that's all we need for now. And so I needed just that. That is the webcam. That's the backlight supporting data line, the backlight supporting line. So this is for webcam. So I don't need the webcam for now, so it's not connected. Let's see what is it that we have. Okay, so as you guys can see, we clearly have something different. Okay, you can see that. So, you see that? And that was what we were not having before. So now, while in this state, so this is a state we need to get the device to get to before you worry about the battery. If you have not achieved this stage, you should not worry about the battery charging, because the charger itself needs to be recognized before it will be able to carry out anything that is post the charger recognition. So the battery in this particular scenario, worrying about the battery, it's not the right process. First, you need to worry about the charger being properly recognized, or the communication of or the communication of the charger and the device. There should be proper communication established between the device and the charger. Now, this might seem very small, but imagine how important it is for you to be able to follow the sequence of recognizing what state your device is, what you need to do first, what you need to worry about first, and what you need to worry about second. A very common, another common example. Remember, we had this issue of keyboard and trackpad not working, but then we realized that the machine powers on. Immediately, the device powers on. You get image on the screen, and the image disappears immediately, which will tell. Now, imagine if in that scenario, three things are happening at the same time. Device powers on, you get image on the screen, immediately the image disappears, keyboard is not working, trackpad is not working. Then you ask yourself, what's going on? If you want to tackle trackpad not working, keyboard not working, screen not working, you will completely you will be doing something completely wrong and different. Rather, you take a step back. What is it that comes, that in this particular case, what's going to be primary and what is going to be secondary? In this case, if why would a screen, and then you also ask yourself, what's the communication between these three: the screen, the keyboard, and the trackpad? I mean, one thing that ties one, two, three together is what? Say again. 5 foot rail. What ties the screen, keyboard, and trackpad together in this particular scenario? What ties them? What's the relationship between the screen, the keyboard? Why is it that the machine turns on, you get your screen activated, you get image on the screen, and immediately the screen goes off? Keyboard doesn't work, trackpad doesn't work. What do you say? What do you say? Farid. I was thinking that, I used to say that Shahid needs to get a refund from school. Your teacher should be arrested, not just a refund. Your school. So do we know where we are? So Shahid is right. What ties them together is angle sensor. That's what ties them together. I have no idea whose student you are. You are not my student. Anyway, so that's what it is. Now you can, so remember what we're doing now. We in the section of the board that's affected by liquid, we have to isolate it because we knew that one section of it is the angle, is the sensor line, and then the other one is, it's what, it's going to be the main line, which we said, okay, fine, we first need to address the resistor that is missing, which we have just done. Okay, the next thing we're going to do is we're not going to see if our battery is what is going to be detected, correct? So we disconnect that, and we now have our battery connected and see what we have. Can I have a battery screw?
But isn't it a good sign that it's showing the
Yeah, it's a good sign. Yeah.
I'm thinking about it, single sense also.
No, no, you're saying wrong stuff. What do you mean makes more sense? It's just you're saying wrong stuff. It's fine. Don't worry. What makes it's fine because the
Single sense of I don't know if
yeah, you already failed. You already failed. You have stop. You already failed it. Stop trying. And then you should you see this idea of you telling yourself you're new. That particular issue has been addressed while you're here. Okay, so because this idea of you hiding behind you're still new, I think that should stop. Anyway, okay, now let's see if our battery let's see if our battery will be cognized. Okay, let's go. See what do we have on the battery. 1%, yeah? You see that? Is that one? Yeah, 1%. Did you say 0%?
1%.
Shai, did you say 0%? Are you hoping that it's 0%,
No,
Shai?
no, I just couldn't see properly.
Why will you see
Just ignored
properly
the camera.
when you have enemies everywhere? You don't want it to work. Okay, so just try to clean it, even though we have enemies that are hoping that it doesn't work. So yeah, 1%. We're just gonna give it a bit of time to see if it increases. And just by the way, what you have now, you see that it's the battery is on 1%. So this information that is displayed, this information, even when this battery increases, it's not gonna increase from here. You understand? Because this information, there's a lapse between at the time that we checked on. So this is a feedback from before. Yeah. So even if it increases, you have to click again. Yeah, to get the current feedback. So just gonna give it a bit of time to see if the battery increases. And then yeah. So afterwards, we are now obviously going to address the other section, which is the current sensing section. And sometimes it also it's also good for you to just to be able to have something in your archive of some of the behavior of a machine, which is in addition to what you're expecting to have in terms of when you have issue on the current sensing line, especially in that region of the board. What you can do is you can actually run the device without having to address that section first and see what happens. Just to see, just to add that to your database of know-hows, and then in the future you will obviously find a way to say, okay, if I have ABC, and then all of these things, basically, it's about uh, being able to have so much of information at your bank of reserve in a way that you are able to tie one to two, and because there is no book, this information do not exist in a book form where you say, okay, if A happens, B is the answer, if B happens, C is the answer. No, it doesn't work like that. You basically have to follow the structure, the structural design, which is the schematic obviously the board view, and what has happened to the device, and then you obviously take it from there. So we're just going to give it a bit more time. So the idea is to see if the battery increases. Now we are 1%, but like I said, this is the feedback from before. So we are going to click again just to see what is it that we have. Yeah.
Approach for the battery, the approach is the same on all other devices.
In terms of
Like you must first worry about why the charger is not. It's not. Why there isn't communication because the issue here was that the device wasn't detecting that obviously the charger connected.
there was no proper
Yeah,
communication.
there was not proper communication. So
Yeah.
if you get another device, let's say an Intel,
Okay.
it's the same. You first start with why is there no communication between the charger and the why isn't there proper
Yeah,
communication?
the process is the same. In this particular case, the process will be the same because in order for your battery to charge,
Obviously, the components will be different because it's different. No, the names of the components and
yeah, the net. So the line. So you see this. You see these lines. They refer to them as net names. So say this, for example, that's going to be your net name. So you see, okay, see here. Look under here. You see where it says version. I'm just going to use this. So here it says version. This is the version of the board that you're using. The part itself is SV103. The pin is pin 4. The net name is PMU underscore RSL, LS underscore RST underscore L. Probe is 0. Now, so that's the net name. So this is the net name. You understand? So you're asking about the net. So the process is the idea is the same. In order for the battery to charge, in order for the charger to charge the battery need to be the battery in this case the battery is going to come as secondary and the charger communication is going to be primary. So if there is if the battery if the charger is if there is no proper communication between the charger and the device, then what comes after that it's not going to be there will be no proper also there will be no proper workflow of what comes after that. The same way happens is if you disconnect your charger, there has to be, I mentioned before, if you disconnect your charger, there has to be a transition of power handover from the charger to the battery. But then you ask yourself, so the transition is seamless. What I'm trying to say is transition is not the right word because when your battery and charger are connected and they are both working on the device, the battery is active depending on what stage the battery is. When we talk about the battery, generally you have three phases to a battery. You have the first phase, the second phase, and the last phase. The last phase is where the battery obviously stops receiving and it just kind of idle. That's the last phase. Now, you say to yourself, okay, when I connect my charger and the battery is connected, but you're talking about handing over, the battery is active and the charger is active at the same time. So when you say hand over, it would make sense if you say it's hand over. If it is that the charger stops working, you when you disconnect the charger, that operation stops and then the battery comes in. If there has to be and then it would mean that the device has to lose power in order to transition into battery power. But that's not the case. Even though they seemingly are both active, the battery and so usually when you connect your charger, to your device, depending on what stage the battery is, the charger is actively powering the device at the same time charging the battery. So back to what I'm trying to establish. I spoke about the charger being primary and the function after the charger, now one of them being the battery, will be secondary. Now the functions after the battery, if I disconnect my charger, you have a battery taking over. If the battery is not detected, of the function of the battery will be when you disconnect the charger, battery takes over, the device stays on. But if the battery is not detected, that part of the battery holding power when charger is disconnected will not be present. In this case, you're not really going to worry about why does the device go off. Rather, you take it from, does my battery take over when the charger is not present? I don't know if I'm making sense. So you have the first one now being charger. Charger handover to the battery. Now, when the charger is disconnected, battery takes over. When the battery takes over, the device should stay on without the charger. But in the situation where the device goes off, yes, you have a device that goes off, but your immediate worry should be, why didn't my battery hold power when the device switched to the battery? Do you understand? So you have one issue, but you find out what is this tied to and what is required for this to before I worry about this. Okay, I think that's about this. So that you see what we talk about, you see the feedback is still one, but if we click again, now we have seven. So that's the current the current. So now we can clearly see that the battery works. So we're going to disconnect, and you can see it stays on. Obviously, stays on. Battery, it's the battery is low. So what we're gonna do actually, before we completely reinstall the device. And then, by the way, another problem that we're having is they could not install the operating system. Actually, so what we can just do now, it's I'm just gonna install the operating system while we obviously, because that will help us see the behavior also of the battery at the operating system level. So, but just so what we're going to, yeah, let me see. That's old. That's the old display. Yeah. So let's do this. It's shut down. So now we're going to need the keyboard connected. And so if that what is it called was properly done, there would have been no need for them to worry with the battery. I mean, but that's that about that. So let's just do this. Let's have the keyboard connected, because now we're going to put the device into DFU and drop the installer into it. Let's have this connected. We need that connected, and then we're going to need the cable, the charging port, one of them connected also. So because we need this cable for DFU restore, that's just the only one we need. And then that's it. That's what we need. And then let's have the cable, the battery connected back. The cable. Stop, please. Don't do that, please. Please. It's gonna be the first port. Okay. So let's go to Apple Configurator 2. We are going to put the device into DFU. Shut it down. To put it in DFU, we need 4 keys: Control, Alt, Right Shift, and the power button. Even while it switches on, don't worry. Just keep holding the buttons, it will go off. I was supposed to count, but I didn't count. So I'm just going to hold the power button and see if I was supposed to hold the 4 buttons, and then I count 10 seconds, and then afterwards, and I hold the keyboard button, but I didn't do that. So let's just start again. So 1 1 1 2 2 3 4 4 5 5 6 6 7 7 8 8 9 9 10 10. Then I let go of the other keys and I keep holding the power button until it goes into DFU. Sometimes it can be tricky that it doesn't go into DFU, but just have to be patient. Have to try again. 1 1 2 2 3 3 4 4 5 5 6 6 7 7 8 8 9 9 10 10. Now we should be, device should be going into DFU. We just hope the cable is not disconnected. We're gonna check that cable again. But I think the cable is connected because at the time, yeah, we had just let's check that again. Just do this and just see if the cable is.
Accessibility shortcuts, 24 items, voice guide. Close button.
Okay, let's see. The cable is yeah, cable is connected. Okay, let's now try to put it into DFU mode. Please connect the power. Okay, I didn't. Yeah, I didn't count. I have to start to see if we. Okay, let's try again. So it should pop up. Let's see, just to confirm something. Okay, can I have a different cable just to be sure? Okay, it's fine. There's one here. Go. Okay, it doesn't seem to go into recovery DFU. So what we're going to do is we are going to um, use an installer to install the operating system. Okay, so we're going to use an installer for the operating system and test the device before we did you check?
Is it not like this?
Oh, okay, so that port even with, see that port, we don't have on that port. I mean, we're supposed to have, so the same that port. There's no data across that port. Okay, something I'm thinking now, but I'm just gonna confirm that I will know from this. Let's see what happens with a different port. So that will tell us what's going on. Uh, let's try a different port. So I'm thinking that okay, but first let's try a different port. Let's see if it doesn't work, then that explains why also the DFU. So you see that blinking, that is okay. That's fine. So when you get when it blinks, now that it's stable, its communication has been established, which is why you have that. So let's just try that again. Let's try that port again. And it also explains why DFU was not established. Let's see. We don't have. There's nothing. There's no. Okay, so that's fine. Oh yes, that makes sense. Why DFU was not established. Okay, that's fine. Let's have it done manually and see that. That's when data. It's yeah. Okay, we should have it popping up. And now let's try again. Let's see. Okay. Okay, so we are going to do manual installations and test the device, see how it behaves, and then we take it from there. Let's see what's our battery on now. The battery is on 13%, which is good. So internet is required. It's standard. Let's have it connected. We have internet connected already. Okay, so the repair itself is done. We are just gonna finalize the repair by having to address the section of the current sensing. But before we do that, we are going to install the operating system, see how the device behaves in terms of the battery and the other function. Yeah, make sure the device works okay, and then but then as far as the actual repair is done, which is battery charger communication and then battery detection, as you guys can see that that is done. So thank you guys. We are just gonna do the software installations off cam and do the necessary test, and then the device will go back to the owner. So just gonna let this do its thing, and that's about it. Thank you guys. I'll see you guys in the next one.